This week, we will continue to develop our fitness club example. Remember last week, we actually introduced a single class called member. And this week, we are going to add more attributes and more methods into the member class. And then we're going to introduce more classes into the projects for the fitness club example. More importantly, you should really realize when you got multiple classes in your projects, it's very likely that objects instantiated from multiple classes that might simply just interact with each other at the runtime. It's a very common phenomenon for object-oriented programming. So that's really the main learning outcome I would like to achieve for this week and also next week as well. All right, so before I start setting up the projects for this week, I would like to point to you, as usual, the extra practice if you're interested. All right, let me refer to you this tutorial series from Winter 19, right? So from last week, as we introduced the OOP, I said you can actually watch from video 34 to video 38. So that's the introduction part for the OOP. And if you haven't done that, but if you're still interested, please still do the work if you wish. And then starting from this week, we're going to talk about a little bit more advanced, more like an intermediate concept about reference type attributes and also array reference type attributes in your class. And so I would suggest maybe starting from this week, you can also watch the videos to see more examples from video 40 to video 46. Okay, so that's what I would recommend. Optional, but recommended if you want to do more in practice. All right, let's now go back to our Eclipse over here. Let's now create a new project as usual, and then we'll do the setup quickly, and then we can do the extension for the member class. All right, so let's now create a new project. Right click on the package explorer and then say new Java projects. Okay, let's type the name week underscore 07 and then say finish. Okay, make sure you don't create the module-info.java file. And we're going to set up the 3 packages to start with. And then we're going to copy over some relevant files from week number 6. We'll do that in a moment. So right click on the source and say new package. And then model. And right click, new package, JUnit tests. And also right click, new package, console apps. Yeah, just make sure you spelled it correctly. All right, so now we got the 3 packages over here, but I will I'll put more focus on the JUnit test as opposed to console apps for this week and next week. But I might still occasionally build some console application to show you what can be output to the console. All right, let's go back to week number 6 and the classes we will need. Let's try to see what we need. Let's say, first of all, under the model, let's simply just copy the entire member class so we can just extend it. So right click and then say copy, and then right click on the model package and say paste. Okay, so that'll be one class. Okay, and let's not worry about any let's not worry about these 2 console apps, right? We don't need them. You can refer to them if you when you review week number 6. And for the JUnit tests, I would say let's just create from scratch, some new test cases. So let's not worry either. So the only class we will need to copy over will be just the member class. Okay, and then let me just create a JUnit test class quickly, and we can start building in a moment. So right click and say new, and then Java JUnit test case. Okay, let's also call that test member. And then make sure it's JUnit 4. That's the version we're using for this course. And say finish. Yeah, just make sure you will be added to the build path. All right, pretty good. All right, let's now try to, before I add any new attributes or methods into the member class, I would like to introduce to you a concept called reference aliasing. Okay, let's now show you exactly what reference aliasing is. The best way to show it would be to really try to create objects and do some variable assignments. That's the way to show it. Okay, in the JUnit test, let me say test over here. Let me give some informative name. So I can say aliasing. Let's say 01. Okay, so that's aliasing. The English words alias simply means like another name. like another name for a person. So person may go by, you know, different names actually. It's quite common, but in the context of OOP, it simply means the same objects. You only got a unique memory address, but the address may be stored in different variables, and and every variable may have a different name. So that's why it's called aliasing, right? We'll see in just a moment. So the easiest way to show this would be, let's say we try to create two members, and to save some typing, I would suggest we actually copy some code from the JUnit test we made from last week. So if you go under week number 6 and go to test member, right? Just double click on that. Okay, it's the same name. Okay, and then if you go to last test case that we created last time, remember the Alan Mark example, we simply copy that. I'm gonna make some adaptation a little bit later. Okay, simply right click and say copy. Okay, and close that. Okay, to avoid confusion. Let's go back to the test member that we created for this week and simply paste. All right, and notice one thing here. As soon as you say paste, you will see under the import, there will be import model.member over here. It's quite important, because in case you don't really have this line, you will actually get a compilation error. Whenever you're trying to use any class outside the current package, so we are currently in the JUnit tests package, and we are trying to make use of the member outside the package. That's why we have to say import over here. Just keep in mind. All right. And let me just also close week number 5 just to week number 6 actually, just to make it more focused. All right, let's now maximize it. Okay. Now here's my question here. Okay, let's say we already talked about, you know, simply initializing Alan Mark two member objects with different weights and heights, right? You remember that's the weights and that's the heights in centimeters, right? And then let me now modify this a little bit, right? You can also try to think about, we can draw some diagram to visualize what's going to happen. The only thing I'm going to change is, let's say only Alan is going to change the weights. Let's say only Alan lost the weights, all right? And now, do you think this test will still pass based on how you understood the previous from the previous week? All right, pause the video and think about it. All right, assuming that you thought about it, the answer is it is not going to pass, simply because let's just double check first of all, and I'll explain why. If I simply just run it, you can see this test simply failed, and to see exactly where it fails, you can see that there is this particular assertion. If you double click, right, it shows to you it's actually the assertion at line number 23 over here. All right. Let's go back to the JUnit test, which is over here. And then if you double click on that, it will show to you actually what's expected should be is actually overweight, but the actual one is actually obese, right? So remember what happened. Let me just get to the point. Remember for Mark over here, he was initially simply obese. And then in the previous week, we actually also got Mark that changed weights by -13, but I just got rid of it, remember? So that's why Mark should really remain to be obese, because whatever Alan would do to lose his weights should have no impacts on Mark, which is just another object, right? Remember, we actually drew two separate objects between Alan and Mark. They're simply different objects, all right? So what I will do is I'm simply just going to copy this line over here and then paste it over here, right? So now let me make a comment over here for you. Mark's BMI remains the same, simply because over here only Alan changes the weights. Okay, I can make a capital for the name. All right, and then let's now run the test. All right, we get a green bar. Okay, hopefully you're okay so far, right? It's not difficult so far, right? Nothing new. Let me call this O1A, right? Only part A. Let me now go to part B, right? This one just, I put it there just as a reference point for you, okay? So we can contrast. Let me now copy this test over here, copy it, and then paste it, right? Control V. And let's call that B over here, all right? And let me now make a little bit change over here. I want to change just one line, okay? The only line I want to change is this. I want to say the following. I want to say Mark is assigned to Alan. All right. You may not know what this really means, but that's exactly the point. I want to put it there first, and then I'll explain that. By introducing just this single line, if you compare O1B versus O1A over here, the only difference is there is one additional line that's introduced over here. You can see right before we try to say Alan object should be changed the weights by minus 13. We actually try to do this assignment here, assigning Alan to Mark. That's what we do. All right. And now the question is maybe you don't want to run the JUnit test just yet. Is it possible for you to visualize whether or not we'll still pass these two assertions over here? Are we or are we not? Okay, that's the question. All right, pause the video and think about it. All right, assuming that you thought about it, and let's try. The answer is no, the assertion is going to fail. And let's see which one it fails. If I run the test over here, you can see we got the red bar over here. If I double click on this, you can see this assertion actually is failing. However, according to how we understood it from 1A, this should not be the case because Mark, since he didn't change the weights, you can see Mark, which was who was initially obese over here. However, he did not change his weights because only Alan changed his weights. And the assignment over here does not seem to be relevant. Does not seem to be. Okay, let me emphasize. And only Alan changed his weight. So Alan should really remain to be obese, right? What I'm trying to say here is pretty reasonable, right? However, it turns out this assertion fell, but as we saw, it's a red bar. And how can we make it work? To make it work, unfortunately, we will have to copy whatever measure it is for Alan and then replace that for the current measure for Mark. And then, let me run it again. This will give us a green bar. All right, so hopefully you can see the process I'm trying to build over here. It's really important for you to see how we go from 1A over here into 1B over here. Let me say it again, and then I'm gonna visualize to you on the iPad and debugger as well. It seems like after these initial initializations for Mark and Alan over here, Alan is overweight and Mark is obese. However, after this particular change of the weights by minus 13, that seems to be only impacting Alan. That seems to be. However, it turns out it's impacting both Alan and Mark. Why is that? And the only cause for this phenomenon here could be just the extra line we introduced over here, which is about Mark is assigned to Alan. Well, but what does that really mean? Right? That's something I would like to explain to you. Okay, let me illustrate this on the iPad. Before I do that, let's simply just get rid of this particular comment, right? It's not applicable anymore for 1B. Okay, just get rid of it. All right, and then I might just amend the comments later once after the explanation. All right, so we're gonna use debugger and also iPad, the paper at the same time. So I would suggest we put a breakpoints maybe right over here. Line number 36 is right before. It's actually right after we have executed all these lines, which we already traced in detail from previous week, so we don't need to repeat. And it's going to be right before we execute this particular assignments, which I'm going to explain about why it will cause aliasing. That's what we will do. Okay, let's now try to launch the debugger. So double click on the tab and go back to Package Explorer. Let's now right click on test member, and then you would say debug as JUnit test. All right, and once we do that, we're going to switch to the debug perspective, and then it's now right before we try to do Mark is assigned to Alan, right? And then remember how you can actually record the addresses for the objects. You can see if you click on Alan here, you got this address over here, 12D, etc. And also Mark, you can also see the address over here, 4C1D, and something just different, right? That's something we were going to do as well. Okay, let's now try to catch up the pace for tracing also on the iPad, and then we'll try to simulate, synchronize between the two tracing methods. All right, first of all, let's now see the review very quickly. Okay, basically, you can see we actually got two object creations And the first one is basically here. We say member Alan is assigned to new member, and then we call the constructor, and then we pass the weights to be 85, and also the height to be 175. And we spoke about how to trace this last week already. So for this part, I will refer you to the video from previous week. If you really got trouble, speak to me in person. I'll trace it again together with you. So what this will do is it's going to create a new object of type member. You can see this is this will be the structure for the member objects. If you refer to the attribute declarations in the member class, you see exactly these attributes as we spoke about, right? For that part, you should also know. So let me paste it over here. Oh, did I copy that? Let me just do it again. Okay, let me just copy that, and then let me put it here. So the first object is over here. Let's put the member here, and I don't need this anymore. Okay, let me just copy this again. Okay, so this will be and that will be the blue one, and then you can see this one here. We the weights is going to be 85 by using the constructor, and the height is going to be 175, and then the address that's going to be stored into Alan variable, right? So that means diagrammatically, Alan is pointing to this particular object. And what's that address specifically? Let's see very quickly, and just to be synchronized with the Eclipse debugger. And of course, when you are following me, for your Eclipse, the address might be slightly different. That's okay, as long as the addresses for Alan and Mark are different, then you're definitely on the right track. Let's take a look. If I go back to the debugger, and then let's see the address for Alan. Let me copy that down. It's 12D, and then 4BF, and 7E. All right, so that's the address for Alan. Right, I just copied that down over here. And then let's do the next line. And for the next line is actually member Mark is assigned to member 101 and 181. Right, it's simply just another object. So what I will do is I'm simply just going to create another object here, and let's just be just use pink over here, and then that one there is going to initialize the weight to be 101, and also initialize the height to be 181, and the address for this object will be stored into another variable. You can think about these two variables are simply of different names, right? Alan versus Mark, and at the moment they simply store different addresses at the moment, right? Since they are variables, they might change later. So Mark stores the address of this particular object diagrammatically. We will simply say Mark is pointing to this this object here. What's its address? Let's take a look. If you go back to Eclipse here, let's copy that. Mark will be let's see, 4C, 1D, and then 9D4B. 9D4B. Right, so that's the address. Right, you can see I got these two addresses over here, and you can do the same exercise when you're following the video. So we simply got two addresses that are simply different. All right, and then if you try to assert the equals over here, they will simply pass. For that part, I'm not gonna bother you. All right. So now the question is, how do we interpret this particular line over here? That's really important. Mark is assigned to Alan. All right. What you can think about, right, for this is your very first example for understanding about reference aliasing, so I'll go a little bit deeper into the details. You can think about Alan is basically this particular variable box that stores the address over here, 12D, 4B, F, 7E. And also Mark, over here, Mark is actually storing another address over here, and then the address is over here, right? Let me copy that. 4C1D, 9D, 4B, right? So that's the address for Mark. Think about, it's basically like pretty much like when you're copying values between two integers. For example, if I got, it's really the same problem. Let's say I got I here, and also I got J here. Let's say I stores 23, J stores 46. If I say I is simply assigned to J, what's going to be the consequence? That simply means whatever that is stored in J, which is over here, is going to be copied over to I, and then override its existing value, and then 46. So basically, the consequence is whatever that is stored in J is also going to be stored in I. The consequence will be I and J will actually store the same value, right? Let's apply the same principle over here. So now let's see. Let me use the orange over here. So when we say Mark is assigned to Alan, okay, let's write down the principle over here. Copy the address stored in Alan, the source of the assignments, over to Mark. So that's exactly the semantics for executing variable assignments. So copy whatever that's stored in Alan and store that into Mark. Okay, so you can see Alan is over here, and copy this address over and store that into Mark. So that means Mark is not going to store this address anymore. It's going to instead store the same address. Let me just put it in the same color. So that's 12D, 4BF, 7E. Diagrammatically, how can we change that, right? You can see before this variable assignments, Mark is actually pointing to this particular pink objects. However, this address has been overwritten already to the blue one. So that means Mark, rather than pointing to this object over here, is now going to point to just the same objects as pointed to by Alan. That's basically what's happening over here. It's really important for you to see from variable assignments for primitive type, like an integer, into how you do variable assignment for addresses, like for reference type. It's really important. All right. So the consequence will be, let's draw that. Mark, after this particular variable assignment here, we're going to have this. So Mark, rather than pointing to this object over here, Mark is now going to point to this object here, right? And you can try something over here if you like. Okay, I'll write it here. If you simply say assert true, and then we can say Alan equals Mark. Hey, that's something we can try. Actually, back to Eclipse, we'll do that in a moment. And this is actually going to be passing, right? This will actually be okay. It's not going to fail because after this, at the moment, Alan and Mark, they are really pointing to the same objects, meaning that the address that's stored in Alan, the address that's stored in Mark, they are simply the same address, which is this address over here. All right. So far so good. And then what we want to do now is go back to Eclipse over here just to verify it's really this address that's really being stored into both variables. Let's double check. Okay. If you go there, and then you can see we're now over here. As soon as we say step over, right? It was which address is going to change. You can see Alan's here, and also Mark is over here, right? The address for Mark is going to be changed. So currently, I'm simply moving my mouse over Mark. Let's you can watch out the change over here. So if I say step over, you can see for Mark, his address has been changed into this particular one. That's actually simply the same as Alan. You can see, right? You can see that one actually shows to you. It's highlighted. Alan and Mark, they simply just got the same address, right? You can see there's no change over here, right? All right. And now we're gonna execute another 3 lines before let's switch back to iPad. How do we visualize the rest? Now, let me use maybe red over here. How do I understand the execution for this line over here? It's also very crucial over here. Given that Alan and Mark, we simply say Alan and Mark, they are reference alias. Okay, it's like aliasing. Okay, you can think about that's what we talk about for aliasing. Because for the same objects over here, this single object has 2 names. Either you can access the object using the name Alan, or you can access the object using the name Mark. Either way is okay. And using either name to do some change is going to impact the same objects. Let's see exactly why. So now, if I try to say here, Alan is the context object. So when I say Alan dot, remember we said the dot is more like a dereferencing operator, like an arrow. So Alan dot over here, and then we simply call change the weights by method, and we spoke about how you can trace this last week. So I'll let you refer to the notes if you're not certain about this. And then minus 13. So what I will do is Alan dot is going to we're going to invoke the change the weights by on this object over here, and minus 13. So that means the weight over here minus 13 is going to be 72. All right. However, it's really important to know this. Alan is going to get access to this object over here. At the same time, Mark is also going to get access to this object over here. So now if we try to call Alan.getBMI report, and also let me just be consistent with my color. So let's say Alan.getBMI report, and also Mark.getBMI report, right? You can see, even though syntactically, right, you can see Alan and Mark, they seem to be different context objects, but they're actually the same context objects, because you can see Alan and Mark, they are really pointing to the same objects over here, right? So now let me write it down. It's really important to remark on this one here. So what I will do is I'm just going to put it over here. Okay, Alan and Mark. So point number one. So context objects of different names. Right, you can see it's Alan versus Mark is simply different variables. On the other hand, number two is actually the same. The names of the context objects, they are names denoting the same context object, right? So these 2 points are equally important. Alan and Mark are simply different names. However, they really refer to just the same objects because of this particular variable assignments. Okay, so these 2 points, just make sure you know them. All right. All right. So after this, if we say Alan.getBMI and Mark.BMI, you can see even for Mark.BMI, that's something we were puzzled before. If you're only changing the weights for Alan, why would it also impact Mark from obese into also normal? It is because even though you're only using the name of Alan to change this object over here, but this object, because of this variable assignment here, is also being pointed to by Mark. That's why when you say Mark.getBMI report is also going to use the measure of 72 and also 175. That's why they are simply the same. All right, I hope this makes sense to you. It's about reference aliasing. That's the simplest example I can think of to really illustrate to you about the reference aliasing. Okay, I'll go back to Eclipse, but let me recap very quickly for you. Okay, it's really important for you to review about what 01A and 01B. And the only difference is about Mark is assigned to Alan. So you really want to compare the differences between the two test cases. And also to really understand very thoroughly about why, after this particular assignments, it is the case that Mark is not pointing to this object anymore, but pointing to this. Rather than saying Alan is not pointing to this object, but Alan is pointing to this object instead, right? You can see it's also possible, but that's not what's being achieved by this particular variable assignment, right? It's really important. We'll do another example for reference aliasing, but it's really important for you to think about this simple one. Let me just go back to Eclipse over here, and then let me just show you one more thing very quickly, and then we are done for this example. All right. So now you can see Alan and Mark, they are really pointing to just the same object here. You can see let's just remember it's the 12D, the address starting with 12D. All right. So now if I say step over, and now if I step into, what will be the context object? The context object will be referred to by Alan, but it's going to be the object of 12D over here. If I say step into, you can say the context object, this is the 12D object here. That's something I want to show to you. All right. And we don't need to trace the rest. I simply say step return. And then if I say step over again, so now if I say Mark.getBMI report, it's a different name. It seems like, however, it's really denoting the same context object as I illustrated on the iPad, right? So now the Mark should also be of the same address, 12D as well. So that's why if you say step into, the context object is still 12D over here. That's why you would simply just get the same BMI report as Alan. They are really pointing to the same objects. Okay. All right, let me stop this, and then I'll do one more line, which I promised you to do. Let's switch back to Java perspective. And let me go back to test member. And of course, you can stop the JUnit test over here. Right after this particular variable assignments, you can say the following. Assert true. And then mark is equal to Alan. So now after this, you know what? Let's do even more contrast over here. You can see assert false. You can see before this particular assignments, before that, Alan and Mark are simply the results of the two object creations. So that's why it should be false, that their addresses are the same. However, after this particular line, after doing the variable assignments, there will be the aliases to the same objects. In that case, they should be the same, right? Notice the difference here. All right, so now if I say execute the test, you can see I got a green bar, right? So study this carefully, and let's do one more exercise about reference aliasing.